Okay, I think we're on air. Hello. Yep, microphone is on. Webcam is on. Screen is there. Perfect. Beautiful. Okay, so some people are starting to tune in. For those that are already there, welcome. Guys, I'm super happy to be here. We're just gonna wait a couple minutes. It's not yet 12, so I'm gonna wait until it's 12 at least so we can get things started. But thanks everybody that has tuned in as of now. Okay. Let's see here. Okay. That's going to be a good crowd. A lot of people tuning in. That's cool. Trying out this new microphone. Hopefully it works. Hello. Yeah. I think we're there. Beautiful. Let's give it a couple more minutes, guys. Thanks to everybody that's there already. Just going to give it one more minute and we'll be good to go. Blue Jays Cup. Couple more seconds. Okay. A lot of people have tuned in already. I think we can get things started, guys. So I am super excited to be here again, guys. For those that were there on the last webinar and have come again for this one, I thank you very much for tuning in, taking some time out of your day to hear what we got to say and to share. So today, guys, we're going to talk about sound insulation of light wood frame buildings, the house. So I think a good idea would be to start up with just showing you a quick little video about who AcoustiTECH is and what we do. Some of you in the audience right here knows who we are and have worked with us in the past, but probably some of you have never heard about us in the past, and this is the first time you have heard us speak or present anything. So I think it would be a good idea to introduce to you guys a little bit who AcoustiTECH is. So I'm going to show you a quick little video and then I'll be back. So also just want to point out, I'm going to be playing some videos throughout the whole presentation. So if you may, please just adjust your volume. I don't know how the volume is going to be translated to your computer. So if it's too high, just make sure you turn it down a little bit. Let's go. Okay, so guys, that was a super quick video just to show you a little bit about what our everyday looks like, either going on a job site, performing some acoustical tests, being in our laboratory, and obviously on that video you saw a few of the projects that we have worked on. Particularly one that you may have noticed is the Chateau Frontenac, obviously a project that we worked on, but the reason I wanted to include that is because I just want to share with you where we're from. So we're a family-owned business. We have been doing soundproofing for the last 20 years, and we are super passionate about what we do. We are a small team, but we provide a lot of expertise to the table when it comes to soundproofing. So hopefully after today's presentation, guys, you'll be able to go back home to your projects with a little bit more knowledge about sound insulation of light wood frame buildings, which is what we're going to talk about today. So 4 things that we're going to focus on today, guys. 1, we're going to define general acoustic principles. 2, we're going to demystify propagation of noise in different materials. 3, we're going to demystify sound insulation of floor ceiling assemblies, particularly today about light wood frame buildings. And 4th, we're going to recognize proper acoustic solutions. So if we get to it, guys, I want to talk about this before we get into the specifics of acoustics. So who we are and what we do. So who is AcoustiTECH is one of the questions that comes up the most. So first off, I want to mention that we are a manufacturing company. We have a great experienced team. We have acoustical engineers that work with us. We have our own laboratories where we do a lot of R&D, a lot of research and development, and we do a bunch of tests either there on our on job sites with third-party acoustical companies. However, we don't have all the products in the world. So that is one reason why we decided to go out and partner up with what we think are one of the best, some of the best acoustical companies out there, whether they're from North America or from Europe. We have partnered up with companies like Fermacell and Suprema, so that altogether we can bring a lot more solutions to the table and not just for one specific type of assembly, for example. So what we focus on, guys, and what we're going to be doing, what we do is offer guidance and solutions for people who are frustrated with either possible acoustic complaints and or lawsuits, customers' negative perception of their buildings, new code regulations, acoustics and weight, for example, and just the abundance of products and unclear information that is out there. I'm going to try to share as much information as possible so none of these become a frustration for you. So if we keep going, guys, let's talk about some acoustic principles. I think it is super important to just go over the very basics, even if I've done it before on previous webinars. I think it is very important to talk about the basic acoustic principles before we get into the real details of light wood frame construction. So, auditory perception of the sound level. So sounds have different tones and timbres, guys. Tones correspond to the pitch and timbres correspond to the identity of the sound. Sounds have also different frequencies. So there are bass sounds and there are high sounds. So bass sounds are low frequency noises. So as you can see, they are often related to wood frame buildings. You know, when you walk into a wood frame building and you're walking on it, you're going to have a very hollow boom boom type noise when you're walking on it. So these are low frequency noises. And then you have high sounds, which are high frequency. So this is what most likely you're going to find in concrete buildings. So, you know, when you walk into a brand new building, you're on a concrete slab. If you drop something like your keys, for example, you're going to have a very high pitched noise. So this is why what we identify as a high frequency noise. Now, what becomes very important here to notice is that let's take light wood frame construction, for example. There's going to be a combination of both these types of frequencies because we're dealing with a wood frame construction. So you're going to have low frequency noises. And then most often than not, you're going to have a gypcrete or concrete topping over top, which means that you're going to have to deal with high frequency noises. So see, you guys don't have to necessarily remember this. I just want you guys to understand that whenever we're working on a light wood frame construction building, we need to make sure we're covering both low frequency and high frequency noises. Now, There's also the auditory perception. There are infrasounds, there are also ultrasounds. So infrasounds are anything between 0 and 20 hertz, and ultrasounds are anything above 20,000 hertz. So to put it as simple as I can, these are sounds that we cannot hear. So we're not going to take too much time talking about those. What we need to focus on is the human auditory field, which is everything between 20 and 20,000 hertz. So this is the range of sounds that humans can actually hear. So we need to focus on that. Now, let me just share a little story to you guys. You maybe heard it before, but at some point there was an app that kids could put on their phone where they could have ringtones that only created a certain frequency that kids their age could hear. So they could be in the middle of their classroom, they could text each other, they could hear a ringtone because the message came in without the teacher ever noticing. Because as you grow older, the less sounds you're going to hear, unfortunately. So just a little story there that I wanted to share. Moving forward, guys, there are two types of noises in a building that you have may heard about already. So STC and IIC. So STC stands for sound transmission class, which are airborne noises, and IIC stand for impact insulation class, which are impact noises. So I'm going to talk to you guys about both of these noises. So first of all, airborne noises. What are some examples of airborne noises? So we have conversation, television, music, a dog barking, for example. Now I want you guys to take a look at the top left corner image where you see a bunch of arrows coming out of everywhere. So what does that mean? That means that wherever air can go through, sound can go through as well. So underneath a door, around a plumbing pipe, through an electrical outlet, around a window, basically anywhere where air can go through, sound can go through as well. So let me just tell you a little story about this. I'm often in hotels, not nowadays, of course, because of the whole situation, but I've had so many experiences where hotels try, or at least, put some good effort in having great acoustics, great soundproofing in their buildings. That being said, if there's about an inch of space underneath the door, I'm going to be able to hear everything that's happening outside. And this has definitely happened to you in the past. Whenever you're closing your door and you put your hand up against around the wall and you feel air coming through, that's almost a certain indicator that you're going to hear people outside in the corridors. So little details like this that don't always come up can definitely make a difference in your project. So just remember that wherever air can pass, so can sound. Okay, now the image just below is an example of how we test STC noises. So in one room, we're going to have a very high quality speaker, and then the room beside, we're going to have a very good high quality microphone. So the speaker is going to create a sound for a certain amount of time, and the microphone is going to pick up on those noises, and that's how you get your STC rating. Okay, so I want to talk about the STC requirements of both US and Canada, because today we have crowds from all over the place, all over the US and all over Canada. So I'm very, very happy about that. So that's why I thought it would be a good idea to cover both. So STC requirements in the US are 50, and STC requirements in Canada are also 50. So STC is something that a lot of people, a lot of builders, for example, tend to focus on, because it's one of the things that perhaps through time became a little bit more important for some reason. So people talk a lot about STC, more so than IIC. However, IIC is super important, and that's why I'm going to head to our next slide, which is IIC, sorry. So what are some examples of IIC? So dropping an object, moving furniture, walking or running, for example. So what I'd like to show you on the left side is just a quick little video of what a tapping machine looks like when we're performing impact sound tests. So as you can see, this is a tapping machine that has a bunch of hammers underneath that create an impact to the surface of the floor. Okay. Now, if you take a look at the image just below, you're going to see the tapping machine on the room above, and you're gonna see a microphone on the room below. So tapping machine is gonna create a bunch of impact sounds on the surface, microphone is gonna pick up on those noises, and that is how you're gonna get your IIC number or result. Now, one thing that I wanna point out here, guys, that is super, super important is one of the things that comes up very often when I'm talking about an acoustical solution. In this case, for example, an underlayment. Whenever I'm talking to an architect, a builder, or whomever it be, a client, the first question that comes up when I'm presenting an underlayment is, well, what's the rating on it? You know, I have seen your competitors and they have numbers like 70, 75, sometimes even 80. So there are a lot of numbers that are being thrown out there that are very, very high and that look super interesting and super performant. One thing that I want you guys to notice is that whenever we're performing an acoustical test for impact, so trying to see what the performance is of an underlayment, understand that we're not just testing the underlayment itself, we're testing the whole assembly as a whole, okay? So we're testing the floor, the quality and the composition of the floor, which is super important. We're testing, of course, the underlayment, the quality of the underlayment. We're testing the structure. Sometimes it's a concrete structure, sometimes it's a wood frame structure, sometimes it's mass timber, sometimes it's steel, and sometimes there is also a suspended ceiling. Sometimes there's not. So everything between the tapping machine and the microphone is being tested. So just remember one thing, the result comes from the assembly as a whole and not just from a single underlayment or product. Of course, that product is going to be super important. However, the end result is going to come from the whole thing. So whenever somebody says, hey, Christian, well, what's the rating on your product? Well, my next question is, well, what is your assembly like? Are you working on a light wood frame building? Is it a concrete building? Is it a steel building? Do you have a suspended ceiling? Because it is very, very hard to compare apples to apples in this industry. All of a sudden, somebody's going to say, hey, Christian, well, I see a product that is being sold at Home Depot, for example, that is 15 cents a square foot, and it's going to give me an IIC of 80. Why should I go with your product? Well, that's a very, very good question. And my following statement would be, well, you should check how that product was tested, because it may very well have nothing to do with your assembly. If that product was tested in a laboratory under a controlled environment with amazing structures that are maybe sometimes 10 inches, 12 inches, and you're trying to equate that to your building that has nothing to do with that, well, sadly, that product that you thought was going to perform at 80, all of a sudden may very well be under the building code. So something to pay a lot of attention to, guys. Very, very important. Now, talking about requirements in the US and Canada, the IIC requirement in the US to respect is 50. However, in Canada, there is no requirement for IIC at all. There is only a recommended minimum of IIC 55. So for all of those that are here from Canada, what I'd like to mention is that even if IIC is not a requirement by code, just know that pretty much all the complaints that I've heard about from either property managers, from people doing renovations, from people moving into new buildings, they're not about them being able to hear their neighbors snoring or watching TV or listening to music. Most of the time, all these complaints come from, hey, I can hear their kids running. I can hear the lady with high heels. I can hear them moving furniture. So all of these sounds are impact noises. So what I'm trying to say here is that even if it's not a requirement here in Canada, it is super important to not neglect IIC. It is very, very important, because even if it's not a requirement, if Mrs. Smith is super tired of hearing their upstairs neighbor jumping and dancing a little Zumba, she's going to pick up the phone and she's going to call somebody. And unfortunately, that becomes your responsibility. So it is super, super important to not neglect. Moving forward, guys, I'm going to talk about 5 super important acoustic principles that are going to be extremely, extremely important for light wood frame construction. We have mass, we have resilience and decoupling, we have void treatment, we have sealing, and lastly, we have flanking. So I'm going to go over those 5 principles. First of all, mass. okay? So we have two walls. Think of the left wall as it being a concrete structure. Think of the right wall as it being a light wood frame structure. And the two balls that are being projected, they are both air sounds with the exact same energy, the exact same speed, they're the exact same noise, okay? As you can see, light wood frame, which is at the right side, gets dropped almost instantly. And on the left side, the concrete structure moves a little bit, but doesn't get destroyed. So what does this mean? And the easiest way I can put this is what a lot of people tend to say in this industry is that concrete structures are always going to be better for soundproofing. They're always going to be more performant for acoustics than a light wood frame structure. And they're right to some extent. And the reason being is simply that the more weight, the heavier your structure is, the more mass you have, the less air sounds are going to go through. So as you can see on the left example, since it's a concrete building, since it's heavier, it has more mass, it has more weight, air sounds are not going to go through as much. On the right side, however, light wood frame structure, the reality of a light wood frame structure is that since it's more sensible, since it's lighter in weight, since it's not as dense, air sounds are going to go through more easily. Okay, so just remember that STC is related to the mass, the heaviness, and the weight of the structure. So whenever somebody says, hey, a concrete structure is always more performant than a light wood frame structure, they are right to some extent. They are right when they're talking about STC most of the times, but not necessarily when it comes to impact. So I'm going to talk about that in the following slides. Now, resilience and decoupling. Okay, this is super, super important, guys. So we have three examples, right? On all three, we're talking about light wood frame construction. On the balls that are coming down, those are impact noises, all with the exact energy, the exact same force. Now, on the left example, you're going to see a light wood frame structure by itself. As you can see, the ball drops down and it barely bounces, which means that energy and impact is being transferred to the unit below. Now, what a lot of people do is use a concrete or gypcrete topping. Most of the time, people use this for acoustical purposes. Now, let's take a look at that example. We have a light wood frame structure with a concrete or gypcrete topping on top. We have the mass, the impact that is coming down. However, if you notice, the ball doesn't bounce a lot. Almost exactly the same as the example on the left. What does that mean? It means that yes, gypcrete and concrete topping are super important in light wood frame construction for acoustics. However, if you remember the previous slide, it has a lot more to do with STC and with air sounds because you're adding more weight, you're adding more mass. So air sounds are not going to go through just as much. However, in this example, we're talking about impact. So as you can see, the ball doesn't bounce much, which means that energy and impact is being transferred to the unit below almost just as much as the previous example. Now, what we should be doing is the example on the right. So this is the importance of decoupling. So you have your light wood frame structure, you have a concrete or gypcrete topping on top, and you have your impact being created on the surface. However, there is a resilient material. There is decoupling happening in between with some type of an acoustical mat, for example. So as you can see, the ball bounces a lot more, which means that impact and energy is not being transferred as much to the unit below. So this is exactly what we need to be doing, decoupling material, guys. So separating materials. Now, let's talk about void treatment. So let's think about the two examples on each side as them being wood frame construction. The balls represent an air sound, so STC. As you can see on the right, the wall goes down. However, on the left side, the red strings represent bat or blown insulation. What does that mean? That means that when air sounds try to come through, they're significantly slowed down by that bat or blown insulation, which means that your STC is going to be a lot better. Your air sounds are not going to go through just as much. So that is why it's super important to have bat or blown insulation in your cavities. Now, next example, ceiling. And it's exactly the same principle as I explained before with my example of a hotel room. So think of the blue-black liquid as it being an air sound. And think about the little crack you see in the box as it being the space underneath the door. So as you can see, wherever air can go through, so can sound. So sound is going to go through wherever space you're going to give it. Okay. And last but not least, flanking, which is super important, which stands for the vibration of the structure within the same level. So on the left example, you're going to have, well, on both sides, you're going to have an impact noise being created on the surface of the floor. However, on the left side, you're going to have your light wood frame structure, you're going to have a resilient material, and you're going to have a gypcrete or concrete topping. However, the mistake here is that you have a partition wall over the concrete or gypcrete topping, which means that if there is an impact being created in one room, that same vibration is going to be transferred to the unit on the side. As you can see, everything is bouncing. However, on the right side is what we should be doing. So we have our light wood frame structure, we have our gypcrete and concrete topping. However, the partition wall is right there, and these were poured separately. So if there is an impact in one room, that vibration is not being transmitted to the room just beside it. So that energy is not being transferred. So there's a lot of ways we can control flanking. And flanking influences greatly the performance, as it says. And it's one of the easiest and cheapest principles to control. Okay, so how can we mitigate flanking? So there are 4 ways we can do that. 1, we can decouple masses between the wood frame and the concrete topping with a resilient material, as you just saw previously. 2, we can decouple the floor covering from the concrete topping, of course, with a good acoustical underlayment. Most of the times, what we recommend is that when we're installing our flooring, we lift up the underlayment up against the wall about 2 inches and then simply cut off the excess. So this way, that energy and that impact is not being transferred laterally, and it's not being transferred to the walls. Third, by decoupling gypsum boards, for example, with an acoustical clip. And last but not least, by decoupling baseboards and coaterbands. So creating a little bit of space so there is no transfer of energy. Now, what I'd like to do now, guys, is just show you a quick video that will show you just how sound travels within a structure and how much it can get amplified. So I'm going to get to that video right now and play it for you. So guys, as you saw, this is the tiniest thing. So this is a small music box that we simply played by itself, then put up against the wall. And you could see just how much that sound was amplified. And notice that this is not a sound system. This is not somebody jumping on the floor. This is the tiniest thing. And this is why it's so important to decouple materials, because anything can transfer energy and can transfer sound and even amplify it to some extent. So moving forward, guys, everything has a unique sound identity, okay? So what I want to explain to you guys here is that if we have 4 different instruments all playing the exact same notes, the curves are going to look completely different. So a violin, a trumpet, a flute, and an oboe, they're all playing the exact same note here in this example, but the curves look completely different. So what am I trying to say here? What I'm trying to say is that we cannot approach one structure the same as every other type of structure. In other words, I cannot treat a steel structure the same way I'm going to treat a light wood frame structure, the same way I'm going to treat a concrete structure. because they're all different by nature. So it would be wrong for me to come here and say, hey guys, I have this amazing product, use it in all your projects and it's gonna be great. So the way we approach it is that we need to find out what type of structure we're working on, and then afterwards make a recommendation of what are the solutions that are gonna get you where you need to be, because every building has a different requirement. In this particular case, light wood frame. And light wood frame is gonna have a very different reality than a concrete building, a mass timber building, and a steel building, for example. So moving forward, guys, let's talk about concrete versus wood, okay? So one of the most frequent questions that come up is, well, can light wood frame structures be more efficient than concrete structures? A lot of times people are gonna say no. Concrete structures are always gonna be better than light wood frame structures. However, I'm here to tell you otherwise. I'm here to tell you that light wood frame structures can be just as efficient and sometimes even more efficient than concrete buildings. So let me explain to you why that is. So if we take a look at this example right here, we have a typical concrete structure, 8-inch concrete slab, no suspended ceiling. So why is it that a concrete structure can be just as performant as light wood frame? The only reason is because we have very little room to get creative with light wood frame. Well, I'm sorry, with concrete structures. So we only have one area where we can make sure we're doing a good job, and that is with an underlayment underneath the floor, right? With some type of acoustical solution underneath the floor. So we only have one area that we can control. That being said, even if light wood frame construction tends to be more sensible, tends to be a little bit more complex, there is an enormous, there are a lot of places where we can get creative, right? So first of all, we have the floor finish, okay? So there is a wide range of efficiency of what the flooring can provide, right? So an engineered floor, a vinyl floor, a laminate floor, a ceramic tile, a 3/4 inch floor. Every single floor has its own qualities, therefore they have their own different performances. So we have seen results of different floorings providing 3-4 points more than another one. So the quality of the floor finish and the composition of the floor finish is definitely something to consider. Not a lot of people think about it, but it's absolutely important. Now, second thing is the acoustical membrane, which can influence your result by up to 5 points. And normal rule of thumb is that you need to try to get as close as possible to the surface, the source of the impact, if you want to be able to mitigate it more efficiently. So an acoustical membrane is super, super important, as you can see. Then we have our gypcrete and concrete topping, and as I said, this normally is always there for STC, for airborne noises, because it adds more weight, it adds more mass. Now, what is super important for impact though, is a resilient material underneath. The decoupling material that is going to be underneath the concrete or gypcrete topping, which can bring sometimes up to 14 points, which is major in your end result. Then we have our OSB or plywood panels. We have our joist, I-joist, web joist. Then we have our acoustic insulation, so batter blown insulation. Normal rule of thumb is that for every 2 inches of batter blown insulation that we add, generally we tend to get about 1 point more. Now, afterwards, we're gonna have resilient channels versus clip systems, okay? So I wanna take a little bit of time to talk about this, guys. And the reason being is that resilient channels are still one of the things that I see used very frequently in light wood frame construction. And I have nothing personally against resilient channels. The only thing I do have against is that they're often badly installed. What I'm trying to say by this is that whenever guys are going in with their drywall, they're installing, they're screwing in, they're going through the resilient channel and they're touching the joist, okay? If it happens a couple of times, it's not that big of a deal, but most often than not, it happens a lot in a ceiling. So what happens when we create all those points of contacts with all those screws? We're short-circuiting the system and we're creating a bridge where energy can go through. So the whole purpose of your resilient channel is not there anymore. simply because of an installation mistake. So how we can go around that installation mistake is with solutions like clip systems, where you're going to completely avoid having that type of problem of touching the joist, which becomes basically impossible to do. And that way, you can bring up your result between 5 to 7 points more, which is a lot. And last but not least is the number of drywalls that you're going to have underneath. Most of the time in Canada, we tend to see 2 layers of drywall, most specifically in Quebec. However, in the US, I tend to see a lot more 1 layer of drywall. Now, having 2 layers of drywall instead of 1 is very, very important, because the same principle as the concrete or gypcrete topping, you're adding an additional layer of weight, of mass, therefore helping you not having as much air sounds go through. So definitely something to consider, guys, having 2 layers of drywall instead of 1. Now, one thing that I want to point out here is, your typical light wood frame assembly versus the potential of where it can be, okay? So the example on the left is your typical light wood frame assembly, like I just explained before. So you have your flooring, you have some type of underlayment underneath, you have your concrete topping or gypcrete topping, you have a decoupling material underneath, then you have your batter blown insulation, you have your resilient channels, and you have, in this example, 1 layer of drywall, okay? Which can give you a result on IIC between 47 and 53. So if you notice, guys, there is a lot of chances that you don't get to the minimum IIC requirement, which is 50, right? Because here, we're not exploiting, we're not exploring as much. We're going with a very basic structure. That is why most of the light wood frame assemblies that we have joined after there has been complaints, they're often around that range, 47, 48, 49. So not reaching what they should be reaching, which is a very, very least a 50. Now, at the right side, you have the potential of where it can be. Your flooring, good quality flooring, of course, a good underlayment, your concrete or gypcrete topping. Then you have a good resilient material underneath. You have your batter, your blown insulation filled up to 100% if possible. Excuse me. Then you have, instead of a resilient channel, you have an acoustical clip, therefore not circuiting everything. And then you have 2 layers of drywall. So where can you be? What's the potential? So instead of being between 47 and 53, all of a sudden you can be between 60 and 66, which is amazing, amazing performance, especially for light wood frame construction. When generally a concrete structure can be anywhere in the mid 50s, all of a sudden with light wood frame, if you're doing things right, you can be between 60 and 66, which is amazing. Now, I've been talking about ratings for a little while now, 50, 55, 60, 65, whatever it may be. However, not everybody knows what that sounds like. So I think it is super important for me to show you the difference between a 50, a 55, and a 60 in a light wood frame scenario. So I'm gonna play a little video for you guys.
Hey guys, what's going on? This is Christian from AcoustiTECH again. Have you ever wondered what's the difference between different ratings? I mean, obviously you know that there's different numbers in different ratings, and I'm talking about impact sound ratings, IIC ratings to be more specific. But have you ever wondered what is the difference to the human ear between, let's say, a 50, a 55, and a 60? Let me show you.
So as you guys could see, first of all, what I want to point out is that there is no such thing as not hearing anything. There is no such thing as completely soundproof, okay? The only thing we can do is make the sound more muffled / more comfortable. So as you could see, the difference between 50 and 55 and a 60, it was simply that the sound was more muffled and it was a lot more comfortable. Therefore, you have a better performance. So hopefully this little example showed you guys what the difference is between different ratings. Now, moving forward, guys, we spoke about solutions with concrete topping, generally what we tend to see. However, I think it is super important to talk about other solutions that are out there. We personally have nothing against concrete topping. However, there are some people that have expressed some disadvantages with working with concrete or gypcrete topping. And I would like to talk to you about those. So what are the advantages of some solutions without a concrete or gypcrete topping? Well, first of all, the ease of installation, quick execution, because there's no need to wait, there's no drying time, there's no controlling the humidity in the building, right? Also, there's no concrete leveling required. And one thing that becomes very, very important sometimes is the charge, so the load, because normally a solution that doesn't involve concrete or gypcrete topping decreases a charge over your structure of about approximately 20 pounds per square foot, which sometimes can definitely be a game changer. So what I'd like to do now, guys, is talk to you about two different solutions that can bring that value, that can bring performance without ever having to use concrete or gypcrete topping, okay? So in this particular case, let me introduce you guys to a solution that is called AcoustiBoard. So these are panels that are loose laid. They're applied directly over the plywood, and then a flooring can be applied directly over top. So the panels go out on the floor, flooring goes directly over top, and most of the times this is a solution that is used with an acoustical clip. You can get results, if you can see right underneath, STC between 56 and 59, and IIC between 57 and 61, which are incredibly performant, especially for a solution that has nothing to do with gypcrete or concrete topping. What I'd like to do now is show you guys a little video of what that solution looks like and how it can be installed. Just a second. Perfect. So this solution, guys, may very well be the solution that you've been looking for. If you're trying to find a solution alternative to concrete or gypcrete topping, super easy to work with, extremely performant, and we definitely recommend it. Now, the other solution that I'd like to talk to you guys about is what we call a dry topping solution. So this is a solution that is a combination of gypsum and recycled paper, along with a very performant acoustical material underneath. So this is a system that is also in panels. Now, one of the main advantages of using a product like this, which is a product from Fermacell, is that we can lay it directly over the plywood, and afterwards we can install ceramic tiles directly on top, which makes it super versatile. Then if we have a 3/4 inch floor that we want to nail, we can nail directly on top of it without needing any additional layers of plywood. And then there is no worries about the transitions of different rooms if you have a combination of 3/4 nailed down floors with ceramic tiles, because you can be using the exact same panels for everything. And they can bring great performance as well. As far as STC, we can be between 57 and 61. And for IIC, we can be between 54 to 62, which is amazing for a solution, again, without concrete topping. So I'm going to show you a short little clip so you guys see how this product is installed. So just a short little video so you guys see how this product is installed, which saves a ton of time if you're comparing it to a wet screed, so a gypcrete or concrete topping. So these are two solutions, guys, that I definitely recommend you guys considering if you're looking for alternatives to concrete or gypcrete topping. If you're used to using concrete or gypcrete topping and that's what you like to use, you've never had any issues with it, I encourage you to continue. However, do take into consideration the tips and tricks that we gave you in through this presentation. Now, going towards the end of the presentation, guys, how does it work with us? For those that have never worked with AcoustiTECH in the past, how do we work together? So normally you would say, hey, Christian, you know what? We're working on this renovation project or in this brand new project. Could you guys help us out? So we have three different ways that we can help you out. First, we have our own laboratories where we can recreate scenarios, test them right then and there, and figure out what the best solution is for your project. For example, hey, Christian, we've never tested this vinyl floor in this specific scenario. How would that work? So it's something that we can do. Second thing that we can rely on is our database where we have thousands of tests. Throughout the last 20 years, guys, we have been able to collect an incredible amount of tests in our database. So we can go through all those tests, gather everything that applies to your project, and give you an accurate recommendation of what you should be doing in your project. Third thing is that we can go directly onto the field, perform some tests there, either with our team, with an acoustical team, all together to bring to you the best solutions. Then afterwards, we pretty much give you a prescription, we like to call it, of a good, better, best type scenario with different solutions, different combinations of solutions, and with different budgets. Something that would give you a good result, a better result, and a best result. And it all depends on your project. And that is a decision that is up to you guys to make, because sometimes you're going to be working on a high-end luxury condo, and sometimes you're going to be working on affordable housing. So the needs are not the same, and we understand that. That's why we do this type of recommendation. And afterwards, obviously, as always, we offer on-site support. Now, one last thing that I want to mention to you guys before I leave you is our amazing tool called AcoustiTECH. So what I'm going to do is I'm going to play it on the background. Don't worry if you don't have any sound in the back, that is completely normal. What I want you guys to notice is just how it works. So this is an amazing tool called AcoustiTECH. All you have to do is go directly onto our website, acousti-tech.com. Afterwards, you go onto the acoustic index. What you can do there is you can have access to an amazing database of tests that we have. So what you can do right there is you can select your structure of the project you're working on. You can select the type of installation. You can select the floor covering. You can select whether or not there's a suspended ceiling. You can select if there's a minimum IIC that you're looking to hit or a maximum. And you're gonna get results of tests that we've performed that equate or that relate to your project. Then afterwards, all you got to do, you take a look at the test that we have shown here. You can click on the test, and then you can simply email us and say, hey, Christian, I'm interested on XYC test. Could you please send us the report? Could you please send us more information on it? So just notice, guys, that in this platform, we don't have all the tests in there because it'd be way too overwhelming. We have too many tests. So if there's something that you're looking for that you cannot find there, please make sure that you send us an email, give us a call, and we'll be happy to go through our database and try to provide something that would be worthwhile for you. So afterwards, guys, let's go through the recap and takeaways, okay? So it takes us to the end of our presentation. So wood frame structures equal great potential. So as you saw, light wood frame construction is more sensible, it's more fragile, is more lightweight, and you need to pay closer attention to them. That being said, it doesn't mean that they're not performing. It doesn't mean that they're a bad structure. It just means that you have to take a look at it a little bit closely. And if you do things right, they have amazing potential. They have great potential to be super, super performant. Second thing I want you guys to remember is that IIC is not to be neglected. Even if STC is one of the things that comes up the most, IIC is something to not neglect because it can easily get you in trouble. And that is one thing that I would like for you guys to consider so you never have to experience owners, people moving in, complaining about their neighbors walking around, moving furniture and things like that. So it's not to be neglected, guys. It's super important, even if it's not a requirement by the building code here in Canada. Now, third thing that I want you guys to remember is that the result doesn't only come from the product, from the solution, okay? The result comes from a complete assembly. Everything has its place. Everything plays a part on your end result. The flooring, the solution, the structure, whether or not there's a suspended ceiling. So everything comes into play and becomes super, super important. Fourth thing is that if you follow the principles that I just explained today about mass, about decoupling, about resiliency, about STC and how to control them, you're absolutely 100% going to have a successful project because it's all about having the right product at the right place, okay? And last but not least, better acoustics equals less frustration. No other way I can put this, guys. That is why we're here, to bring less frustration to the table. If we can bring any kind of expertise, any kind of solution that will help you not have any frustration because people are unsatisfied by their acoustics, my job is done. That is exactly what I like to do with you. And the last thing that I want to mention, guys, is that I'd like to give you something just for being part of this presentation, what we call the light wood frame recipe book. What we've done basically is that we have gathered results and all of our database of what we have on light wood frame structure, and we created a recipe book where you're going to have a lot of different tests. And I'm just going to quickly show you what that looks like, guys, here if I can. I cannot access it. However, this is about a 10-page document where you're going to have a lot of different assemblies that you can have access to and take a look at what the results are with XYC assembly, with different types of floorings, with and without concrete topping. So this is an amazing tool if you work with light wood frame structures. I will provide this for free. All you need to do is send me a quick email to me or to anybody from our team saying, hey guys, I'd like to have the recipe book, and I'll be more than happy to send that over your way. Now, before I leave you guys, everybody's still there. Before I leave you, I do want to mention that we have an upcoming webinar next week from the NFCA, where we're going to talk about high IIC numbers. There's a lot of questions coming our way with super high IIC numbers, and it's going to be an amazing presentation. And if you're enjoying what we do, I strongly suggest that you attend. It's called NFCA. If you have not received the invitation, please make sure you let us know, and we'll be more than happy to send that over your way. So guys, at this moment, we still have a little bit of time, about 7 minutes. If somebody has any questions, I would like to answer them. Now, I'm not super familiar with the questions bar right here, but if I can answer some of the questions that you have typed in, I'll do it right now. I'll be more than happy to do so. For those that are done, they don't have any questions, I want to thank you so much for being there. It was an amazing hour that I got to spend with you, and hopefully you have some brand new information that can help you with your work. So thanks so much for being there, and hopefully I can see you again. Now, I'm going to go through the questions that I have here and see if there is anything I can answer. STC minimum requirement is also 55 under CBC. Andre is also 55 under CBC. I'm not sure I understand your question, Andre. I'm sorry about that. If you could send me an email, I'd be happy to talk to you. I'm just not sure I understand. Let's see here. Sherwin, I suggest, yeah, that's a very good question. Please give me a call, as it would take a lot of time for me to respond to your question here. Some very good comments. Thank you guys, by the way. Beautiful. Okay. Well, there was a lot of comments, guys. There was some questions in there. I suggest that you guys either send me an email directly, give me a call, and I think you'd be better served if I respond those questions that way. So guys, again, thank you so much for being there. It was a pleasure to spend this hour with you, and hopefully I see you guys again soon. You guys have an awesome day. Take care.